Hi, my name's Millie. I'm a biologist and I work in our applied sciences group. I'm here today at the Global Innovation and Technology Centre in Cambridge, and I'm going to be talking about some of the really cool projects that we have going on at the moment. We're down in the optics lab. I'm here with Richard Claridge. We work together on a biomimicry project, which we're trying to work biomimicry into more of the things we do at PA in applied sciences. Richard, can you tell me a bit more about how biomimicry fits into the work we do in applied sciences?
So we use science when we need to push beyond the bounds of conventional engineering. When we think about conventional engineering, we think about electronics, we think about data science, we think about the tools we're all familiar with in our day-to-day lives. But they have limitations, they have rules, and sometimes what we need to do and what our clients need to do require us to go beyond those rules. And the way we do that is by employing new science. That's why we're in an optics lab, that's why we have quantum devices, and that's what biomimetics and biotechnology let us do. They let us use a different rule set so we can do things we can't otherwise do conventionally. Millie, why don't you give us a couple of examples of where we can take inspiration from biology to do new things?
So there are three different ways that you can take inspiration from biology and from nature. The first way being bio-based inspiration, which is directly using the biology to do the thing that you want to do. And a really good example of this is using a slime mold. You can use slime molds to create efficient networks as sort of a biocomputer. They can also be used as inspiration for algorithms to do your computing power. The second way would be to take inspiration from how nature does something, but then copy that with our conventional technologies or conventional equipment. A nice example of that is the electric eel has been copied, and the way that it generates electricity has been replicated with hydrogel, something that we already have and use, to create bio-based batteries. And then the third way would just be taking inspiration from how nature does something, how it thinks about it, and using that either as an algorithm and making a computer program, or just taking inspiration from how something computes in nature. I'm here with Matt Hartley. We're in our manufacturing facility. We're standing in front of one of our pool pack machines. Matt and I worked together on the first market launch of the pool pack bottle. What are you doing at the moment with pool pack bottles?
Well, so since your involvement, we've had our first market launches and now we're getting ready to go bigger and better. So we've got machinery now that can make 10x the number of bottles for the future upcoming market launches.
I think what's really cool about the pool pack technology is that instead of just doing small innovations in sustainability and kind of bumping up the sustainability of a product, it's gone completely radical, and instead we made plastic bottles equivalents out of paper, which is really cool. So it's quite a brave approach to sustainability. I'm here with Rob Lambert. We've worked on defence projects together, and more specifically how to bring biology into defensive thinking.
I'm interested in, for you, as a biologist coming into a different sector, how's it been for you?
I found it really interesting coming into the defence world. Biology isn't something that's that integrated into defence. So I think historically, bioengineered materials has been quite used, bioengineering in general, and then also the area of sort of biological and chemical defense. Beyond that, there isn't really that much biology that has integrated itself into the defense world. So it has been really interesting doing a project where we've dived into biology and how useful it could be and where it applies, and seeing that actually it is applicable across lots of different areas of defense and can actually be really useful, especially when we're thinking about strategic thinking in defense.
How do you think the world of defence has responded to your ideas?
I think there's been quite a lot of interest about the biology world. We spoke recently at an electronic warfare conference about biomimicry, and there was a very good reception about how we can use biology and basically the billion years of evolution that biology has already done for us, the ways of thinking of how things work, and applying that to defensive concepts has been really interesting, and has been taken up by lots of different people as an interesting area.
So what do you think we should do next?
Well, I think what's really interesting about biology is that you can create this direct analog between evolution and how nature adapts and evolves very quickly, and map that directly to defense and how we innovate new technologies and new ways of thinking. So I think what next for biology would be taking that thinking and that billion years of evolution and adaptation and mapping that to evolution, and basically just learning from what's already been solved and achieved for us by nature.